Hi everyone, hope you are doing all right. Today we will be talking about the force and extension in a spring related to the aspect of Hooke's law by Science Time IGCSE course. But before going through this video, I will be asking you to subscribe my channel, like, and also please drop a comment, any suggestions, any improvements. I will be very happy. And if you haven't turned on the bell yet, please do it. So let's go. So at first, let's have a brief introduction about the Hooke's law, F equivalent to Kx. Whenever we hang a load on a spring, it applies a certain force depending on its mass, W equivalent to mg. And as the mass of the object increases, the spring stretches more. So now we notice that the extension is directly proportional to the force which is being applied by that load. But until a certain point, which from that point onwards, from that moment onwards, the extension ratio would be totally different and it's not going to be no more constant. That means the extension is not going to increase at the same amount. Sometimes it cannot increase and sometimes it is going to increase in different amounts. And the spring won't regain its original shape anymore. So as the limit of proportionality of extension and force is exceeded, the spring won't regain its original shape anymore. This is because it cannot work appropriately anymore. So the formula is F equivalent to K being multiplied by X. F, as you know, is the force acting on the spring being measured by Newton, N, and K is the spring constant. For instance, if that K is 1000 Newton per meter, defines that if 1000 Newton is applied to that spring, its extension will be 1 meter. And also X is the extension itself. Or in simple words, extension, or let's say X in this case in the formula, is the distance which the spring is going to be stretched from its original shape, which is being measured in meters since we are talking about distance. So as you can see in the picture, the left picture is the spring balance, which we can notice the force being applied to it accurately, and also in the right picture, a normal spring. So, and now let's talk about the proportionality. K is all the times something constant for a specific spring, for a certain spring. It's not going to be flexible, it is not going to be changeable because it's related to the elasticity of the spring. Therefore, based on the formula, which is F equivalent to Kx, as the force being applied increases, the extension will also increase. But this statement, as I said, is only true when the limit of proportionality hasn't exceeded yet. And when exceeded, this statement is not going to be true anymore and it is going to be different. The energy being stored as the spring stretches is called the elastic potential energy. And also, as you can see in the picture, we notice that when the limit of proportionality hasn't exceeded yet, the force and extension are completely proportional. So as you can see, when nothing is being hanged in the spring, the extension is 0. When a certain load, for example, let's say like W is being hanged in that specific spring, the extension will be X. And if that W will be doubled, that means 2W will be hanged in that specific spring, the extension will be 2x. And guys, don't forget this. If the stiffness, or let's say the K, will be different for different springs, that means when we are going to add W, like a certain force being applied to one spring and its extension, for example, it is X, if we are going to hang the same W, the same load, with the same mass, with the same weight, to that in the same place, indeed, because in that case the gravitational field has to be something constant, so the location is important. And if you are going to hang the same W, the same mass, below into another type of spring with different kind of K, indeed, the extension would be completely different based on the formula which it says F equivalent to Kx. So if K is going to be different, which defines that the type of that spring would be different in one investigation, indeed, the extension would be totally different. So now let's, for comprehending the concept much better and much more efficiently, let's go through a couple of questions. Question number 1. Which statement best describes the Hooke's law? Most of the IGCSE students, teenagers, they are going to get stuck in this question, which is pretty much really simple. Choice number 1. The extension of a spring is directly proportional to the force applied, provided that the limit of proportionality is not exceeded. Choice number 2. The extension of a spring is inversely proportional. That means as that increases, the other one decreases to the force applied, provided that the limit of proportionality is not exceeded. Pay attention. Choice number 3, the last choice, the extension of a spring is directly proportional. As that increases, the other one also increases to the force applied when the limit of proportionality is either exceeded or not exceeded. It says no difference if it is exceeded or not. So pause the video and think about it. Answer to question number 1. So, guys, the answer is choice number 1. And why? Since as the force being applied to a spring increases, the extension will also increase at a constant ratio. Don't forget this. But this is true when the limit of proportionality is not exceeded. And if exceeded, there won't be any relationship between the force and the extension. That means there is a difference when the limit of proportionality is either exceeded or not. There is a difference. Because if it is exceeded, there won't be any relationship between the force and the extension. It will be increased in different amounts and not in a constant ratio. Question number 2. A spring extends elastically by 10 centimeter when a force of 20 Newton is applied to it. What force would be needed to extend the spring by 5 centimeter? A, choice number 1, 14 Newton. Choice number 2, 10 Newton. And the last choice, 5 Newton. Pause the video and think about it. So, answer to question number 2. A spring extends elastically by 10 centimeter when a force of 20 Newton is being applied to it. So, what force would be needed to extend the spring by 5 centimeters? So, indeed, the answer will be the second choice, 10 Newton. And why? Since based on the proportionality of the force and extension, when F is equivalent to 20 Newton and extension, or X in simple words, is equivalent to 10 centimeter, if X would be halved, as it is written, into 5 centimeter, 10 to 5. So indeed it is halved, 10 divided by 2. So indeed the force would be also halved, which in this case, F1 is equivalent to 20. So F2, indeed, it will be 20 divided by 2, equivalent to 10 Newton, which in this case, it is choice number 2, B. The last question, a spring extends elastically by 10 centimeter when a force of 2 Newton is being applied to it. What is the value of the spring constant? Choice number 1, 0.2 N over M. And guys, don't forget this, that units can be different. And it's not only N over M. Choice number 2, 2 N over M. C, the last choice, 20 N over M. Pause the video and think about it. answer to question number 3, the last question. A spring extends elastically by 10 centimeters when a force of 20 Newton is being applied to it. What is the value of K, or in other words, spring constant? So the answer will be choice number 3, 20 Newton per meter. Since, based on the Hooke's law, which is F equivalent to Kx, we have to divide the force by the extension to get the spring constant as it is written in the formula. F over x equivalent to K, the spring constant. So in that case, we have to ensure that all the units are based on SI units. So in that case, we will be... and also, guys, it depends on the choice. If it was written N over centimeter, no need to convert that 10 centimeter into meter, because the answers are not in SI units and the denominator is centimeter and not meter. So in that case, as we see in the choices, it is N over M. So in that case, 10 divided by 100 equivalent to 0.1, 1 over 10 in other words, meters. So in that case, force divided by extension, 2 divided by 0.1 equivalent to 20 N over M. And guys, this 20 N over M defines that if to this specific and certain spring, if 20 Newton is being applied to it, that means a load which is 2 kilogram is applying force to that certain spring, 1 meter, the extension will be 1 meter. Don't forget this. So guys, that's all for today. Don't forget to subscribe, like, and share. And if you haven't turned on the bell yet, please do it. And also, our next video, it is going to be related to the same aspect, the Hooke's law, but in this case, the K and the length of the spring and their proportionalities. So, see you in our next video.